All right, so we're gonna start this. Gonna start chapter 5, covering 5.1 monomials. Call this part 1. Scientific notation is gonna be part 2, and that'll kind of be another video. So my videos won't be so long. Okay, so hopefully we can get this done in 10 minutes, and then my other video will be done in 10 minutes as well. Split up into 2 days. Alright, so talking about monomials, I guess the first thing we need to do is have like a definition of that. A monomial is a single term or a single product of variables and numbers. Okay, so the definition of a monomial or examples is it's like a single product of factors would be a good word to say. Single product of factors. So, for example, I guess just several examples here of monomials. It's like I say, it's one term. I kind of call them terms. So, 3x, that would be considered a monomial because it's a product. There's only one term there. All right. Well, even you could have 3n squared times n. That's a monomial. Only thing going on there is multiplication. So that's a monomial. What's not, and I suppose giving an example of a not a monomial, you have what, 3y plus 5. Okay? Now that there's addition, there's two different terms here. Okay? 3y and 5. Therefore, this expression here is not a monomial. Spell that right? Monomial. There we go. Okay. So yes, no. Kind of notice the difference. Even if you have subtraction going on here, it's not going to be. It would not be a monomial. Okay. All right. Coefficients. I talk about coefficients. I guess the coefficient of an expression or a monomial is the number that's out in front of the variables. Okay, so in this particular case, the coefficient is a 3. Even if we had, say that we had x squared times y, what would be the coefficient of this monomial? 1. Okay, there's no number out. There's a number out there. We don't show a 1 because anything times 1 is just that anything. So there is a 1 here, but we don't show it. Okay, so that coefficient here is 1. All right. So the word coefficient, coefficient. So how you spell coefficient? Close enough, right? All right. Well, next thing, negative exponents. One of the things we want to kind of get to is talking about negative exponents, being able to simplify those or make them positive. So our first thing here is, let's see here, we have negative exponents. So a rule of negative exponents, for example, if we have x to the negative 3, to make that exponent positive, does anybody know what we need to do? No. First thing we do here is all we got to do, we take the reciprocal of the entire power. So what I do here is I just take the entire power and I put it in the denominator, and then the exponent automatically becomes positive. All right. So negative x. This is how we deal with negative exponents. Well, let's say that we had something like 2. Call this a, this b. Let's say we had 2 over x to the negative 2. This is a common mistake for everybody right here. Okay, because they think taking the reciprocal of this means the 2 needs to go down on the bottom. but it's not necessarily the case here. Okay, I have -2, x to the -2 here. To make this power positive, I just take the reciprocal of this thing. Okay, I leave this alone, so it's not the reciprocal of the entire fraction. So basically what I'm saying is I just take this and I move it up top, and what I end up getting here is 2 times x squared. Okay, so if you have a negative exponent, it's in the numerator, put it on the bottom, make it positive, just that factor. Okay, if it's in the denominator, you have a negative exponent, take it, put it up top, just that factor. Okay, don't flip the entire fraction. Okay, so me saying the reciprocal might not necessarily be the case or the true. Yeah.
I have a question. If you have an exponent of x to the -2, would you have to flip it because that's going to become positive?
X to the -2.
Right? Because if you take your
You gotta flip it, you gotta put it over 1, you gotta put this in the denominator, because right now you have x to the -2 over 1. So you want to take this and put it in the denominator, so then it becomes 1 over x squared. That's the rule. Okay? Very similar to this right here, same thing. Alright? That's the idea of negative exponents. Negative exponents. Product of powers. Product of powers. So, product of powers. Anybody know what I'm supposed to do when I have a product of powers? What am I supposed to do with the exponents? Especially if I have like bases. So, for example, if I have x squared times x to the 5th. Anybody know what I do with my exponents? I add them, exactly. So I get x to the 2 plus 5, which is x to the 7th. Okay. Well, the same thing goes if the same thing goes if I have negative exponents. So let's say that I have y to the 5th times y to the -6th. What do? I add them. Okay, nothing changes. Okay, so I add them. I end up getting y to 5 plus -6. In this particular case, I get y to the -1. The rule of thumb is that I'm never supposed to leave. This is not simplified. What's simplified is an expression that does not have negative exponents. So obviously I'll have to perform the rule what I did before. It'll be just 1 over y to the 1st, which I really don't need to show the 1. Anything to the 1st power is anything. Okay, so if I have y to the 1st is equal to y. Alright, that's what I'm trying to say. So I don't need to show the 1 right there. I do need to show the 1 here because obviously that 1 is -1. That's a big difference between the original 1. Yes?
Is it y to the 0, isn't it 1?
Y to the 0 would be 1. Anything to the 0th power is 1. Anything to the 0th power is 1. Okay? Yeah. Alright, so that's the product of powers right there. Add exponents. Right? Add exponents. Quotient of powers. Quotient of powers. So quotient of powers, I'm dividing. So again, when I'm talking about powers, I usually have to have what? What do I have to have if I'm a product of powers and quotient of powers? I have to always have like bases. Okay, so keep that in mind. So quotient of powers. I'll say that I had x to the 8th divided by x to the 3rd. Okay, if product of powers I add, what do you think I'm going to do when I'm dividing? Subtract them. Okay, so this is exactly what I do here. So this equals, I'm dividing here, so I subtract my exponents. So I end up with x to the 5th. Okay. And then you think of it this way, what happens if I have, incorporate negative exponents in this situation? For example, let's say that I had x cubed divided by x to the -5th. exactly. You still subtract. I mean, that's another way you can think of dealing with negative exponents, especially if you have like bases like this. It still becomes x3 minus a minus 5 equals x to the 8th. Notice if I would have took this factor and moved it up top here, if I would have called it x cubed times x to the 5th, what would I have gotten the same way? It would have been x3 plus 5, and then also x to the 8th. So either way you'd have done that, you would have got a similar answer. Okay, simplifying, a quotient here. Okay, so maybe a couple different ways you could have went about getting that answer, a quotient of powers. So the next thing here, we can go over 3 more things, and that's the power of a power, and power of a product, and the power of a quotient. Okay, so just kind of giving you a quick example of each of these. Well, power of a power. Let's say that I had, x squared cubed. Well, it's a power of a power here. So do anybody know what I do with my?
Multiply.
I multiply here. Yep. Power of power. I multiply. So in this particular case, I end up getting x to the 6th. Okay. So the power of power, you multiply. Alright, and same thing goes if you were to have a negative exponent. So, in any particular case. So if I had y to the negative 3 to the 4th power, I still multiply. I still get y to the negative 12th, which if I need to simplify, it'd be 1 over y to the 12th. Okay. So the idea of power of the power. Power of a product, this is kind of important. This is a common mistake a lot of people make. And that is, if I have a product here, let's say that I had 2 times m to the 3rd power. Okay? A product to a power. Okay? Each factor in the product has to be raised to that power. Alright? Each factor in that product has to be raised to that power. So I end up getting 2 cubed times m cubed, which is equal to, we get enough, what do I get? 8m cubed. There you go. Yep, 8m cubed. Okay, so a power of a power, the power has to go to each factor in that product. I'm sorry, power of a product. The power needs to go to each factor in the product. Okay? And then we have, let's see here, 2 over x to a power. Okay, so say 2 over x to cubed. Let's see, here's an example. This was an example. Here's an example. Well, when I have a quotient to a power, the same thing applies here. Okay, the numerator gets raised to the power, and then the x gets raised to the power. So I end up getting 8 over x cubed. All right. What happens if I have an example here where I have something raised to the negative exponent? So let's say that I have y over 3. Well, and it's raised to negative 2. Well, the first thing I could do is if I just took the reciprocal of this, the fraction, and I had it, then I could change that to a negative. So, there's a couple different ways you can do it. You could say, well, I'm just gonna go ahead and take the reciprocal, and then change this to positive. That's kind of what I do a lot. So then this comes to positive when I do that. And then I apply the previous rule where you just, the power goes to each thing. So then the 3 squared, y squared, and I end up getting what? 9 over y squared. Okay? So taking the reciprocal of a quotient like this, because you have to actually take the quotient, because the -2 goes to both top and bottom. So just take the reciprocal automatically, and then that becomes positive, and then apply the power to each numerator and denominator, and then you're good.